Hello all. So in this session, which will be a very short session, we're going to look at the use of the initial and final value theorems, and we're going to use the example we did in the last class. So by the end of this, you should be able to solve directly for the initial and final values of voltages and currents in a circuit using the Laplace transform directly without having to bring it back into the time domain. So the initial value theorem says that the initial value of the function x0, and notice this is a common x, the time domain function at time 0, is equal to sfx of s as we take s to infinity, and conversely x at infinity, the value of the time domain function at time is equal to infinity, is the same thing when we take s is equal to 0. So we're going to look back at our example from the last session, and if you remember, I'm just going to use the last result. You could go back through it again. I'm sure you did it by now. And the last thing we had was the S domain function Vs was equal to 4 over 2s plus 1 plus 2 over s plus 2. Of course, you could have left it in the initial form. I'm just using it in this form. You didn't have to go through all the factorizations and all of that. Whatever was the first result you get, you could have done it with that one. And now we want to find what is V0. So that will be equal to the limit as s goes to infinity, s vs. So s vs will be 4s over 2s plus 1 plus 2s over s plus 2. And as we take s to infinity, you should get 4 infinity over 2 infinity plus 2 infinity over infinity, and then we get 2 plus 2 is equal to 4, which is the capacitor voltage. So you'll see that you end up with the same thing. You didn't have to go through the transformation into the time domain. Similarly, I have Vs again is equal to 4 on 2s plus 1 plus 2 over s plus 2. If I multiply it by s, and for the final value, if I want v at time infinity, this is the limit as s tends to 0 of s vs. So if I substitute zeros in here, I will get 4 by 0, 0, 2 by 0, 0, and it works out to be 0, which is the same result we got before. So if you need to find the initial or final values for a circuit, you don't necessarily have to go through the whole long process of reconverting into the time domain. You could simply use the initial and final value theorems to find it in the S domain directly. So just to summarize, we looked at the initial and final value theorems, and both of them you had to multiply whatever was your function v of s by s, and then for the initial value theorem you look at that function going as s goes to infinity, and for the final value you look at it as s goes to 0, and then you'll find directly in the time domain what the value of the function is. So that brings us to the end of our content on transient analysis. both first and second order circuits and the Laplace transform. And next we'll be getting into the final topic, which is steady state AC circuit analysis.